Hey there, everybody. All right, we're here again, and we're still working with basics of vectors. And in this video, we're going to learn to find the magnitude, or what's known as the size, of a vector. And we're going to do that for vectors that are in 2 dimensions and vectors that are in 3 dimensions. And you're going to find this is a super easy thing to do. Okay, so let's do that then. I've drawn a vector on the screen, and one of the goals I have here, besides the explicitly stated one a moment ago, is that I do want to show you another way to represent a vector that I didn't show you in the last one. In the last one I showed you how to represent a vector kind of like you would an array, like vector AB. You can also represent vectors using single lowercase bold letters. Now when you're writing, it's hard to make things bold. If you're typing, you can make them bold. So pay attention to your textbook and on tests to when little lowercase letters are bold or not. Because if they're bold, they're vectors. Okay, so we got this vector v right there. And the component form of that vector happens to be this when you write it in column vector form. And quite simply, when we're trying to find the magnitude of that vector, we're just trying to find out what the length from the initial point to the terminal point is. And you can imagine doing that using Pythagorean theorem or distance formula, I hope, because that's really all this boils down to. The magnitude of that vector just ends up being a right triangle whose legs are the absolute values of the lengths of those components, the horizontal and vertical components. Okay, now don't worry about the absolute value part, but when we're trying to find the magnitude of a vector v, which is signified by writing the name of the vector inside of absolute value bars. Remember, absolute value is a distance? Well, all right, magnitude is basically an absolute value, in a sense, of a vector. What we're going to end up doing is just squaring both of its components, adding them together, and then taking the square root to find this. A magnitude of a vector can always be found by taking the square root of the sum of the squares of the components of that vector. So in other words, if we square the a and the b for a vector v that can be written as the vector whose horizontal component is a and vertical component is b, well, that'll find us the magnitude. In this case, our a is -4 and our b is -2, so we'd get the square root of 20, which you could also write as 2 square root of 5 if you're trying to leave this as an exact value. Very simple, right? All right. So based on that, go ahead and find the magnitude of each of these vectors. Again, just take the square root of the sum of the squares of their horizontal and vertical components. Now just notice the notation that I'm using right there, but you would have gotten the square root of 34 as the magnitude of this first vector. Then hopefully you recognize the horizontal component here is -1 and the vertical component is -4, so that you're taking the square root of -1 squared plus -4 squared, and you would have gotten the square root of 17 for the magnitude of that second vector. Excellent. And now let's do this in 3 dimensions. And it turns out that in 3 dimensions you're just extending that same idea. I could say the exact same thing, that the magnitude of some vector v is equal to the square root of the sum of the squares of each of its components. Or in other words, the magnitude of v here equals the square root of a squared plus b squared plus c squared. Really simple. You don't need any instructions on how to use that, I'm assuming. So go ahead and use it to find the magnitudes of these 2 vectors in 3 dimensions. Did you get the square root of 30 for the first one? Excellent. Now for the second one, I hope you noticed that there was a j and a k, but there was no I, meaning that you have 0i plus 2j minus 6k, or in other words, the column vector form would have been 0, 2, -6 for that vector, and thus its magnitude is the square root of 40, or 2 square root of 10. That's how you find the magnitude of a vector in 2 dimensions and 3 dimensions. Let's keep on plugging through this chapter. Thanks for watching, guys.